see you. And just click that. I'm going to talk in some more detail about climate science. In all this, picture in your mind, why did God make it this way? How is he expecting us to respond? And also, like Marcus said, although many of the people involved in this kind of thing are not Christians, actually many are, and we have a different responsibility or a different motivation compared to the non-Christians who are involved in these things. So if we start to become interested in looking after God's creation, it does not mean we become exactly like the seculars or the Marxists or the people who believe that the ant is just as valuable as a human. Or we don't have to become like that. We have to find a truly biblical way to understand the situation we are in and how we must move forwards with God. So it's a really, actually, then you end up with a bridge to those people and you can relate. And they are always surprised to see Christians involved in anything like this. My friend, when he first went to a UN climate COP to pray, and suddenly a Buddhist group said, "We have a spare pass. Would you like to use it?" So then he was able to go into the negotiations from a Buddhist group because they were so happy to see a Christian involved. So it can result in some quite good relationships. But we have our own reasons to be involved. They overlap, but they're different. Right, so I'm going to start. I'll share screen now, and it will let me. That one. Fossil fuels. Move you here. I want to see everybody as well. There we are. I'm going to start with a bit about why we, how we understand the whole climate system to change, and then we'll go on to specific things that have happened and will happen. So this first bit is, how do we know that humans are causing this problem now? And from a science point of view, this is an old question. It's been resolved a long time ago. But because there's disinformation and misunderstandings, particularly in political situations, then I think it's worth me spending a little bit of time explaining why we're really very sure. So what causes climates to change? The Earth has had different climates in the past. And the answer is usually it's not humans. In fact, it's never humans, except this time. But the physical steps, you can understand them. So yesterday, I explained the reasons that we go in and out of ice ages. And I didn't have a picture then. Now this might help you. But if the Earth is sometimes closer and sometimes further from the sun, do you see that? Because it's not an exact circle. And so if that happens, so that varies over 100,000 year timescale, really long time. And at the moment, we're relatively circular. And then we go to be more of an ellipse shape. And so that varies how much sun gets to the Earth at different times of the year. And that's critical because of the next point. You get a feedback system in the Earth. So one example you can probably imagine is when there's lots of ice and snow, then most of the sun hitting the ice gets reflected straight back into space. It does not warm the Earth. And so if you have a lot of the Earth covered in ice, then it stays cold because the sunlight doesn't warm it. And right now we're in a situation where this is the North Atlantic or the Arctic oceans, right at the top of the Earth. And it used to be always covered in ice, which was, of course, white, and that reflected the sun. And now it's more like this, where there's quite a lot of patches of sea. In fact, some places are completely sea and no ice because of the temperatures are warmer. And then you have this feedback, because that means the sun warms the ocean a little bit more, it doesn't reflect, and then there is less ice. So then there's more dark sea, so there's less ice, less reflection. You can imagine that, right? Is that you get this positive feedback, and you can also get negative feedbacks where it becomes less so. There are many other feedbacks, but that's one I think people can imagine quickly. Another thing which impacts the climate overall is volcanoes. So if we look at this, this is temperature as from measurements to just around about 2010. And you can see there are times in the blue where you've had big volcanic eruptions. Pinatubo was the most recent very big one, and that was in the Philippines in, I think, 1980 something or 1991. And the temperature of the Earth went down for about 2 days, 2 years. If we go back in time, Tambora was a very, very big one in Indonesia, and it took the temperature down by about 2 degrees for about 2 years. So you can see that, but then it restores because the material that was thrown into the air by the volcanoes, it comes up back down again over that period. So this is another thing which does affect climate, okay? Then another thing that does is that the sun does not stay a continuous intensity. There's a roughly 7-year cycle where it gets brighter. Then you get more sunspots. Have you ever seen sunspots? Little black things on the sun? There has not been any in recent years, not visible. But I do remember seeing some in 1991. I was in Pakistan, actually, and you can see these 4 spots. That is a cycle that happens in 7-year cycles. You also get times when the sun is slightly stronger, slightly weaker, by about 1-2%. But in recent years, we've actually had the sun getting slightly weaker, which is the blue line here. It went up until about 1960 on average, then it's gone slowly, just slightly down a bit. It's just the natural way the sun works. It's burning its hydrogen. At the same time, our temperature has gone up during that time. So in a way, the fact the sun has gone slightly down has helped us. We haven't got as warm as we would do. So the sun is one thing that affects the climate. If you go back a very long time, millions of years, the sun was weaker. In those times, we had a lot more carbon dioxide in the atmosphere. Lots more. It was probably twice what we have now. But that's fine because the sun was weaker, and so the temperatures were not so much higher than now. And if we were to experience a solar minimum, that's the maximum decline in the sun of normal patterns, it would just keep our temperature a little bit lower than it is now, but not much. So we can't pray for the sun to go weak and solve this problem. It's not going to be within the range, you know. And so you come to this kind of attempt to explain why we see fingerprints of humanity, because it was none of those things are causing the current change. So one of the most important change down here, the night times, you maybe notice this, night times are warmer than they used to be. In about 40 years ago, 50 years ago, the nights would be a lot colder than the daytimes because the sun is not there. But now we have this extra blanket of carbon dioxide, and the nights are not as cold. And that has big implications for farming, because many plants require a lower temperature at night, or insects definitely do. So that's one reason we absolutely know that it's caused by the extra carbon dioxide, this temperature change. We can measure more heat coming back to the Earth. We can measure less heat escaping to the atmosphere. So we can measure it compared to when the first satellites were there, where you can do an exact measurements over the last 70 years, and you can see this difference, 60 years. Then more fossil fuel carbon in the air. So if you've done any science, then you might have known about isotopes, that you can have the same element like carbon in different weights. So the carbon which was buried for a long time has got no isotope of carbon-14 because it's all decayed, whereas carbon which has been for a plant recently has quite a lot of carbon-14. So therefore you can measure how much carbon-14 there is in a sample of air, and look, there's much more which is old carbon, not recently cycled carbon now. So we know for absolute fact that that has not come from a natural process. It's come by burning what was buried for a long time, which is coal oil, gas. And a bit of complicated science here, but we know because the tropopause, that's the main bit of the atmosphere where the weather happens, that's been rising a bit. We know that the thermosphere, which is the hot bit, right, very, very high up, about nearly 100 kilometers, that's been coming down. And the bit in the middle, the stratosphere, has got colder. All these are what you would expect if it was the carbon dioxide that was causing the change. And in the meantime, we know from hundreds of records that we are burning a lot of fossil carbon. Because one reason we know how much we're burning is because governments like to tax it. So they control quite carefully how much oil is taken out and burnt and so on, because they tax it. It's a good revenue source. So there you go. There's various reasons why it's humans causing the extra carbon dioxide, causing the extra blanket, this is the reason that we have a warmer Earth now. Now, I've got about 6 of these slides, and they kind of take you through which elements are causing the warming. This is from the UN report, the IPCC, that came out exactly a year ago. So just to get your eye in, anything which is above the 0 line is a warming indicator. Anything which is below the 0 line will be cooling. And what we have observed is this one here, a warming. You see the grey line, the warming is around about 1. And these little lines are called error bars. So that tells you how much confidence. We think it's between 0.9 and 1.2. And so our best guess is it's 1.1. You see that? That's how they work. Error bars are very useful. Now, if we go on. So the first one, internal variability. So from year to year, you have a little bit of natural variation in the climate system. That's because of how much ice is reflecting the sun. That varies a bit. If it was a very snowy winter in the northern hemisphere, you have more snow, so you get slightly less sun warming. So you get this variability year to year or decade to decade. So that you can see that's a variation of a very small amount. It's maybe 0.1 or 0.2 degrees. And then there's another one called natural factors. So you have other ways in which the system will absorb more carbon dioxide or less year on year. And we know that. We've measured that for 100 years now. And so that's about 0.1 degree. And then, interestingly, there's a cooling element here. And the cooling element is from pollution. They're called aerosols. And when you burn things, you always have some soot, which are very, very small particles. It's about it's about 2 micrometers. If you have a lot of that, you end up with a grey sky. You might experience that in big cities because they've changed the way that the sunlight comes. But one effect of those is they do cool the Earth a little bit. So that's actually been quite useful. In fact, in the 1970s, the scientists realized this was happening in quite a large measure, and they suggested maybe it would cool the Earth. And then within about a year, other scientists have come along and said, no, it wouldn't cool the Earth because it's only in some places, not the whole Earth. And so that was just a year or two when scientists suggested the Earth would get cooler, some scientists. And ever since, they've known it's getting warmer. So then the greenhouse gases, that's the carbon dioxide and others, which add a lot of warming. And if it was only greenhouse gases, they'd be adding about 1.5 degrees, maybe even slightly more, because the error bar, that's how well we know it. And so then we end up with a total influence. That's if you take that one and take off that one, you see, you add them together, you end up with this one. So that, if we're looking for what's causing different changes in the atmosphere, we've got it. And so you can look at this in some detail here. Let's do the right-hand graph here. What we would expect from just looking at what the sun did is in blue. The sun and the other natural things, it would be roughly the same, a slight decline. And then the brown line is what we would calculate of warming. And what we've actually observed is in black. It's very, very close. So the modeling that we now do with computers is fairly good, actually, at predicting. We know that because if you take a model from 30 years ago and look at what it's predicted, and when we look at what's actually happened, they almost exactly line up. So the modeling has been pretty accurate, actually. So what sources of greenhouse gases are there? And what do we emit? So let's have a look at this. The most obvious one is fossil fuel burning. It's about 2/3 of all the emissions. And so that is oil, gas, and coal. And then the second, which is about 1/3 of total emissions, is the agricultural system. So when you grow rice in underwater, called paddy fields, you have that in the north of India, I think, then there's a lot of methane that comes from that water. Growing a lot of cattle, particularly happens in America and South America, they produce a lot of methane. And if you cut down trees, that's a land use change, then you're no longer absorbing carbon dioxide to produce oxygen in those areas. And that's a significant change. So I just put in there again, sort of what's happened there. We'll look at this in more detail, but the demand for certain types of food in the world has quite significantly changed in the last 2 decades. And there's a lot more meat needed in the current system than the old system. So then I'm going to say there's another direct cause. Because what is all this energy in fossil fuels used for? It's used for things that we need. So my phone, thank God for my phone. I can be in contact and reach the world with my phone. But to make it involves aluminium and copper and silicon and lots of quite complicated processes. But then how about my walls? These are made of concrete and brick. And to get that out, we had to dig the gravel from the ground, the stones. We had to make the concrete that produces some carbon dioxide in the chemical reaction. Then they came on the back of a lorry, it got built. All that involves energy. So to a large extent, the fossil fuels have produced a happier, a better way of life for many people. But there's a difference between that important good thing and overconsumption. That's when we use things much more freely than we probably should do. And indeed, we waste a lot. So here's some examples of waste. There are people who buy clothes for one occasion, they wear it, and then they say, I can never wear that again because people saw me wearing this clothes. I won't wear this. And then they might throw it away. Now, ideally, somebody else would maybe take that and wear it. At least it would be given several lives. But there are plenty of situations where people just completely waste things. And it is particularly true of the very richest people in the world. So the top 1% of the world's income, which includes most people in the UK, I think. Certainly it's the very rich here are responsible for 50% of all emissions. So just think about that. If they could do something to reduce their emissions, then we would be a long way towards improving the situation. 50% from 1% of humans. Anyway, just so overconsumption is the problem, I think, the biggest problem, because I want people to live in healthy lives with good food, nutritious food, glasses. I don't want people to not be able to wear glasses and be able to keep working to their old age. This is good, okay, but it's development and it involves some energy to produce it and some fossil fuels. So there's a big difference between this and something which isn't really necessary and gets thrown away, but still involves making things with a lot of energy. And then there's development, which is life-improving technology. So if you use your concrete to build a hospital, that's going to improve lives. If you use it to build a sewage system, that's going to save lives, improve lives. There's a difference between that and using your concrete just to make a grand maybe a grand monument that lasts 2 years and then you destroy it. So, but do you see what I mean? There's this contrast between the important and the not so important. Now, okay, I'm not expecting you to see every detail, and we'll zoom in. But this is a graph from the UN Environment Programme that shows how emissions happen. So on the right-hand side, we have the gases in the atmosphere. On the left, we have the type of industry. In the middle, what it is. So you might be able to see if I zoom in a bit, maybe not clearly, but there's a few examples here. So electricity and heat is about 31% of all industry, and it produces lots of carbon dioxide. Can you see this line here comes down? It produces through other industry, chemicals, iron and steel is 5%. Or down the bottom, agriculture, through livestock and manure, about 6%. It comes out as CH4, that's a methane. Or waste at the bottom, which is when in landfill, in piles of waste, you get a lot of decay, and then it is emitted as methane. You see that comes across as methane. So if you had time or your own screen, you can work this out and see, oh, this actually involves almost every area of society at the moment. So to move from a warming world to a less warming world, we have to do a lot about all these things, not necessarily stop them, but change them from producing these gases to not producing these gases. And the good news is we have technologies deployed for almost all of those steps now, and I will go into a few of those in the future. But there are but you can see there's really big changes needed. And if we look at a global picture, by the way, if you want to know more, this World in Data website brings data in lots of really lovely ways to see it. And you can cut it in so many different ways to help understand how the world is. So I recommend our World in Data. It's a non-profit. They have no political affiliation. They're really good. Anyway, so you can see energy is the biggest by a long way. And let's just look at that. Energy in industry was about a quarter, then transport, 16%. So you can see that's the largest thing that we need to change how we get the energy. Waste is a significant 3%, and then agriculture and forestry land use. That's actually, if you add it all up, it's about a third, but there we have it, 18%. So do you see how many different aspects there are and which ones are most important? It's important to know which ones are the most important. For example, aviation, it says here, is 1.9%. Actually, the effect is slightly more than that, but it's at around 2%. Flying is significant, but not huge, And then if we look at different countries, so China is by far the biggest, it's more than a quarter. Then you get the United States, the EU, that's 27 countries. Then India's next. India's one of the largest emitters now. That's a huge change from 10 years ago because you're industrializing so quickly there. Russia, right, I'm just going to say one thing about Russia, which is because Russia's economy is not huge. But you see this one here, fugitive emissions, actually. Here, Russia, fugitive emissions. What do you think a fugitive is?
Criminal.
It's escaping. So you can make lots of wonderful films about people who run away from prisons. That's a fugitive. He's got away, he's run away, and you can follow him in like brilliant films. But these fugitive emissions are leaks. And so Russia has a very productive oil and gas industry, but it doesn't keep the pipes very tight. So you end up that there's leakage out of every single joint, so much so that it accounts for about 3% of global emissions. And wouldn't it be wonderful if you could stop those and you'd have a quick win? Anyway, this one is the World Resources Institute. Do you see that website there? And again, they bring data and help you imagine it. And this particular one is very useful. And then another way just to look at this, and this is important to imagine, is over very long times, how have the changes happened? This is a kind of a moral question. Who's really responsible for the problem? Because although China is the biggest emitter now, over time, it has not been the biggest emitter. That was the United States, or maybe all the countries of the EU. because China's taken off quite recently to become the biggest yearly emitter, but actually historically it's been the USA and India about 3%. Okay, so although India is one of the largest emitters now, over history it's about 3%. And so there's a question, a moral question that goes on: should the damage caused by climate change be paid for by those countries which emitted early on? And there's a lot of political argument about that, and genuine anger and frustration about who caused it. I mean, just think of it a different way. If I come and I smash the window of your house, who should pay for it? It's me. Yeah, that's common justice. That's what the Bible would say. I'm responsible. And so it's not quite the same as that, but there is a similar. So I have to put that slide up to help us picture, but it's not just now, it's old as well. Now I'm going to look at one example of a change that has been happening in my own adopted country. I am English, but I live in Scotland. And so I have to celebrate Scotland because I'm a missionary to Scotland. And Scotland has done an amazing job of changing the electricity sector in just the last 12 years. And so the graph here is the total amount of electricity used. It's gradually going down, partly because there's less industry, and partly because people are using LED lights and lots of ways to use less energy. So, but the gray one is telling you how much of this electricity is generated by renewable energy. And in Scotland, it's almost all wind. There's a bit of hydro, mostly wind. And it's a windy country. And you can see 2 years ago, it was 97% of all electricity, which is just amazing. And we're getting to a stage now where when it's very windy, they have to turn off the wind turbines because we can't use it all. Last year, there were some times when they paid people to use electricity because there was so much electricity on a windy day that they wanted to get rid of it. So this is a huge change. And then we're now planning a lot more wind with long cables that will send the energy to England and to Norway and to other countries. So you can see here, we are building them in the sea. This country, Scotland, is very experienced at building oil platforms in the sea, but can survive very strong winds. And now we're using the same technology to build wind turbines in the sea. And they then bring the electricity to the shore on cables, and then we are going to distribute it around the country. But the interesting thing is, it's very, very cheap now. Even though you have big ships and big, huge towers, they are 200 meters tall, some of them, very, very tall. But they generate so much energy that they repay that within just a few months. And it's 1/9 of the cost compared to gas-generated electricity. So that we're in a new world now where this is now cheap. Yeah. So that will generate about 10% of UK electricity, those new ones. You see how they do it? They have these huge, great ships and massive, great things. Unless you've seen them, you can't imagine how huge they are. They're just amazing things. And then let's look also at photovoltaics. That means solar panels or PV panels. You've probably seen quite a lot of those now because their price has come down so much in the last 10 years. And so who is building the most? India, done quite well really for a smaller country. That's 20 gigawatts of power. But look at China. The last 5 years, it's deployed more solar and wind than all the other countries put together. So that's because they've realized it's cheap electricity. They aren't particularly motivated by the emissions, I don't think. China hasn't quite realized how important emissions reduction is. But they found it's cheap electricity, and so they've been doing that. Same point. And then we'll just look again at the UK. I'm not saying the UK is perfect. We really are not perfect. Okay, there's been stupid decisions by politicians sometimes. and some of this has been too expensive. It could have been done more cheaply. But look at this. This was a day I'd been asked to give a talk in Paris. And so I quickly looked at this website, which tells me the electricity sources at that half-hour period. And I found that the UK was selling electricity to France, Ireland, Norway, these are the red ones, Netherlands, and Belgium. Can you see that? And so it becomes that you can buy electricity from another country when they have cheap electricity, and you can sell it to them. So there's a trading going on through these enormous cables that they built. So that day we had wind at 7.5 gigawatts and quite a lot of solar. What time is it? Oh, that was late afternoon. So there would be more solar during the day, but middle of the day at 1640 time. So that was an interesting day and nice to talk to my European colleagues. Then in January earlier this year, we had a very windy day and we had 20 gigawatts from the wind. So you see, this is much, much more than gas, which is the top one. So I'm giving you an example of an electricity grid, which is decarbonizing very rapidly and giving us relatively cheap electricity. The expensive part of our electricity now is the gas, the top one. So if it's not windy, we have to burn a lot of gas, and that's what keeps our price higher. And this keeps it lower. Okay. And then let's just imagine also this country, the United Kingdom, was the first to develop lots of steam power and burn lots of coal in the 1700s. And so then we used a lot of coal right through the 20th century until really recently when we cut it out of the generation mix and we now have much more wind and so on. So now we're using less coal. Last year we used less coal than at any time since 1757. Which seems an incredibly long time ago. That's when Mozart was in nappies. Amadeus Mozart. And so I'm just looking again at how can we look at this from world data. Over time, it's gone down, having peaked. And if we compare that to the United States, which started later, you see that? Because they industrialized later than the UK. And then they went up and up and up. And they also are reducing, even though they are a country that some of them just love burning coal and they love their big, massive cars and so on. But they have found that it's cheaper, more sensible to burn much less coal and a bit less gas. And then look at the situation for China. Oh, that's the same two below us. China has gone up very much more recently and very, very rapidly. That peak, I think that dip was COVID, and it's gone up. So China is now the biggest emitter and is quite a problem for that. But of course, we're all buying their stuff. Then there's another way to look at this, which is how many people do you have, how much emissions per person? And generally, this has been declining. That means we are being more efficient with our use of energy. And I'm going to go straight past that and past that. If you want to work out how much carbon you are emitting in your lifestyle and your situation, I recommend this Christian organization called Climate Stewards. This is their American site, but they were started in the UK, and there's a UK site. And you can look at, let's say, a flight. I'm flying to Hawaii, to Kona, and I had to look it up. It was about £90 worth of carbon I was emitting, because flights do, long distance flights emit quite a lot of carbon. But you can look at the different things, different foods, different heating or cooling systems. And it's just really, really interesting to see which part of your life you could change to reduce emissions. I would say most YWAMers have very low emissions because we're either students or we live on fairly low incomes. But we do fly a lot. And that might be one thing. We just need to think that flying is quite expensive in terms of the climate. So probably we should fly a bit less or less distance. So I recommend these people. I know the CEO, she is a very wonderful person of integrity, but there are other organizations out there who do carbon offsets, which is where they say, if you give us your money, we'll plant trees. And those often are actually fraud. So it's a real shame to see how some of those things are developing. And that's why we need Christians, honest people, to set the standard.
I have a question. Do you have a question?
Question.
Sorry. I was just wondering, taking trains is better than flying. Is that correct? As far as
Usually, yeah, almost always, yeah, yeah.
sorry,
Um,
I was just curious.
yeah, yeah. Often, if you are, it depends on the distance traveled. If you are traveling a shorter distance, sometimes it's better to have four people in a car drive than go on four people on a train. But flying is usually the worst. So it doesn't mean you should never fly. I don't mean that. I just mean that you have to weigh it up a bit differently. It's not just about the cost. Yeah. I think there's two classrooms that can't really see that. Is it true? I'm going to talk through this very briefly then, because otherwise you won't get the detail. But this is, again, it's a summary from the IPCC, from the UN report, and it looked at which technologies you could change to and save money. So anything which is blue, you will definitely be saving money if you change to it. So that's wind energy, solar energy, and reduce the methane from the leaking of oil and gas. Those things would make money if we could do them quickly, and we are actually. Then there's other things which are quite expensive. Carbon capture and storage. It's very, very expensive. It's probably cheaper to change something else. Anyway, so I'm just trying to say that there are lots of analyses of which things will help you out. And changing to solar and wind is one which we are moving to quite rapidly now because it's cheap. But really, we should move even faster because it reduces emissions. And you may not see the detail, but I'll talk you through quickly. So this is the cost. The cost of solar power has come down since 2000, so only the last 22 years, from $600 per megawatt hour down to about, I can't see, I think it's about 20. So it's come down in an enormous amount. The cost of onshore wind's come down, offshore wind a bit. Battery cost has come down enormously. And then the lines at the bottom are how quickly they are being adopted, so how many are being built globally. So you can see we are in a world which is changing rapidly and is thus giving us the solutions to many of the emissions problems. The key thing is to move fast enough. And ultimately, don't look at the slide, let's talk to me. Ultimately, because it's coming cheaper, people will buy more and build more, and then it will come cheaper again. And so we are in a situation where, let's say 20 years time, almost all electricity will be from wind, solar, and a bit of gas for when there's no wind or solar. And so the reason that we know we're now on that line is because we've seen the decline in cost, and ultimately it is the economy that does it. Here's a fact. Only 0.3% of land surface of the world, if we covered that little bit with solar panels, it would provide all of humanity's energy. So it is really interesting. God's given us so much natural energy, we don't really need the fossil fuel anymore. And let's go. Right, now I'm going to go into one other area of emissions. I've started really quite big picture, like the whole countries, what the whole country or the whole world is at. Now I'm going to come a little bit closer to home, and it's meat production. I said, so look at how China has increased its meat consumption. It used to mainly eat rice and some vegetables. Actually, it's been similar in India. The middle classes in India eat far more beef and chicken than just a few years ago. And it doesn't always give you better health. Often, particularly beef brings problems of diabetes and problems of heart damage. It depends on how you eat it. But you can see that these are quite big changes. And even the United States, which is famous for its hamburgers, they are eating more and more, partly because it's got cheaper. So I just say this to say that we're not living in the same world as a few years ago, one generation ago. People eat a lot more meat. Is that a good thing? Of all the animals on the earth, 96% of all animals is livestock. So we've kind of started to dominate the whole world by lots and lots of chickens and, well, and cows and sheep, this one. And then just 4% are wild animals. Or chickens. Think of how many hundreds and hundreds of birds you see. Hopefully you see hundreds of normal birds. But there are far more chickens in the world than all those birds. And this, like I said, this has changed within our lifetime, or maybe the lifetime of our parents. Really big changes. So, and this one, this graph is again from the IPCC. We're looking at how much carbon is produced when you are growing certain types of protein. So if we start at the bottom, nuts, because nuts grow on a tree, if you eat walnuts or something, then the carbon is basically zero. Whereas, and eggs is quite low. Whereas when you start getting past lamb to beef, the beef actually doesn't fit on this graph. It's twice as wide as this graph. So beef is quite enormously worse than the next one, lamb and mutton. It's about 6 times worse, 7 times worse. So these days in my family, we eat beef about once a week. When I grew up, we eat beef once a week. But in the middle years, we ate it probably twice a week, 3 times a week. So we're trying to reduce back to what our grandparents did. That's our own family decision. Because we recognize that when you're growing a cow, you have to grow all the grass for it, or maybe corn. You have to often cut down trees for the cows to grow. And then they are also producing their methane through farting and belching. And so beef is, I think beef should be a luxury. I don't think we should get rid of it. It does, but some cows do a lot of good. But it matters how you do it. And incidentally, there are people who are doing careful research into how we can help cows fart and belch less methane. And do you know what the most important thing seems to be? Give them seaweed. Seaweed from the coast. If you give them the right seaweed, then they are digesting the grass differently and they produce less methane. So, you know, there may be ways to reduce this number, but at the moment, meat is very expensive for the climate. And there are people, particularly secular people, who say we should all become vegan and eat no meat. I don't believe that. And I definitely don't believe you should force anybody. But I do think it's kind of should be a bit more expensive because it does actually cost us in climate terms a lot. And yeah, then I was going to go on to effects, but that's a kind of a different section. So I think I'll pause here, if that's okay, and have a few questions. If you have questions.
Yes, please, come on. Raise a question.
I'm still kind of forming it, but you know, listening to all this, it sounds like it's a lot of really good news. You know, I'm looking at the charts on Our World in Data, and it seems like just about every country is doing a lot of good and making renewable energy and doing this kind of work. So is the main thing? It's not enough. It's not quick enough. What's kind of? I'm trying to find the exact thought, but can you?
Yeah, I understand. So, but I'm glad you've got that message because a lot of climate communication talks about the doom and the gloom and how terrible it will be. We are moving more in the right direction than ever, but we're not moving fast enough. And in the next section, when I talk about the effects of climate and how it's already changing things and what will happen in the future if we don't make rapid changes, that's more of the doom, but the worry side of it. Gotcha. So the key thing is to move more rapidly into the things which are economically sensible. And the main thing that's slowing that down has actually been the oil and gas companies putting out wrong stories and wrong information to persuade people that we should go slowly. And that is a sorry situation. It's the sin, actually. It's the greed of they want to keep making money the way they know how. And so they poison people's minds to think, for example, you probably heard this one, particularly in the West, that the climate always changes, so this isn't a problem. The climate always changes, but this one is a problem. It's the reality. This one is a problem because it's going fast and because we are used to living in a certain climate. But they suggest this. If you're on Facebook or Twitter or whatever, you get these messages that say, oh, come on, climate change isn't a problem. It's always happened and we'll adapt to it. We will adapt to it, but let's adapt to less of it, please.
And I've heard a lot about this whole global net zero carbon emission and how it's a big topic right now with like United Nations and other initiatives throughout the world. How on track from what you've seen and studied and also attended at those conferences, how are we doing in that way? Is it going, are a lot of countries meeting that initiative to complete be net zero by their goals? Are they falling behind? How's that looking?
Okay, so overall, we are much closer to track than we used to be, but we are off track. In fact, the very worst scenario, which was if we carried on like we had, let's say 10 years ago or before Paris, it would probably lead us to a 6-degree warming, which is really disastrous. Instead, we're now heading for about a 3-degree warming, which is still going to be pretty serious. But we need to get to a less than 2-degree warming, really, to survive. Now, they use the word net zero, which is the idea that we would absorb as much as we're emitting. And then once you get to net zero, then the Earth does not warm anymore. Within about 2-3 years, we know it will stabilize in temperature, or within a decade. But you still have a warm Earth with lots of energy. And I actually believe we should be net negative, where we should be restoring closer to what we had 30 years ago, because we need to absorb carbon and get back to a less energetic environment. Otherwise, we will have a lot of sea level rise and other big problems. And we don't need those. We can definitely, I'm sure we can have a whole society where we absorb more. So a net positive. There are some companies, some enormous companies. Have you ever heard of Unilever, which produces things like washing up liquid and all sorts of household goods? Their declared aim is to be net positive. So they are working out industrial processes that absorb carbon dioxide. So there's a lot of work in that direction. If you want detail, go to the Carbon Tracker website, and they track where the different pledges are, and which countries have good pledges and which ones don't.
Thank you.
Ben, what do you say about the synthetic beef? What this Bill Gates is saying about
synthetic beef? So this is the idea that you can grow beef now in a lab, where you can, if you have all the right proteins in your petri dish, you can grow meat which is exactly like the beef, and it obviously does not involve lots of land. It does not involve lots of grass. It does involve other things. I think it's very promising. I think some of those things may give us good quality food at a much cheaper price. There's another sort of synthetic which is called fermentation. It's precision fermentation, where it's a bit like the way that people grow cheese. You can grow particular types of meat protein. So it's still quite early days on the second one. The first one is developing quite rapidly. It could become much cheaper. If it ends up cheaper, then your beef burger will be much lower impact. Yeah, maybe. See, humans are very ingenious people. ingenious for good and ingenious for bad. So let's have for good.
Yes. Good question.
Yeah, what do you think are some ways that we do actually need to modify our diets overall?
So there's different angles to this. I'm talking from a climate angle, but of course, modern Western diets are not very healthy, particularly where you've had very processed grains or very processed meat. It is clearly resulting in cancers and heart problems and diabetes. And so there's several reasons why we should move away from highly processed food to more nutritious food. And I believe that coincides quite well with ways to farm which produce less emissions. And interestingly, in YWAM, we're discovering lots of people. God has been speaking to several different groups in YWAM to develop types of farming which bring much better nutrition. There's a dear lady I know in Australia who was in frontier missions for so many years, but she got kicked out of all the countries for evangelism. They refused to give her visas. So then she said, what do I do, God? And God said, stop that. Now I want you to buy some land and to start farming, and I will show my glory through this. And she finds that not only do they have very, very good relationships with their non-Christian neighbors, but the young people who are skeptical of Christianity, they come onto her farm and they farm together with her and they discover Jesus. So there's a lot of this. And in parts of Africa, there are YWAM teams doing something called Farming God's Way. And Farming God's Way involves principles for composting and low till. That means you're not turning the soil. And they produce very much better food for many, many years because it stops soil erosion. So actually, YWAM is one of many organizations where we're finding the solutions to this. To answer your question a bit more, though, is it Catherine? I think.
Yeah.
Is overall less processed food, and I think definitely less meat. I don't mean no meat. I would give you an example from my family. My grandmother was a very wealthy woman. They had plenty of money. Money wasn't the issue, but they ate meat 3 times a week. So upper class English society, 3 days a week. These days, many people in the West, they eat something for breakfast, something for lunch, something for evening meal. All of them are maybe a bit of chicken or a bit of pepperoni or a bit of beef mince. I mean, we could cut out one of those or 2 of those and still live very, very, very healthy, maybe more healthy. And the carbon weight would be much less. The other thing, though, Catherine, is where does your food come from? And we are trying to find the kind of food that is grown well. Often that's organic, but not always. Sometimes it's local, not always. We are very, very careful not to buy beef that has come from South America, because it almost always involved cutting down rainforest to produce that beef. And that's a problem. And I haven't touched on a different topic because I don't really know much about it, but about animal welfare. Because I know Christians who, looking in detail at Genesis, they realize that if we're supposed to look after animals, we should not put them in cages which are this big and just eat the meat. It doesn't seem like a God-given glorious step, but I can't really talk much about it. I notice when the Holy Spirit is stirring in other people, and I think, oh, maybe I'll learn that one in a few years' time. But for now, I observe it and think, oh, maybe I'll have to care about that in the future, but God hasn't touched me yet. But, you know, animal welfare, caring for animals, you do see people who are extraordinarily good at connecting to the animal. And you think, that is glorious. There's something beautiful there. But most of us buy our chicken without any thought of where it comes from, or how many chickens died to make one piece of meat. So yeah, I'm not pushing this strongly, but I just think it's something that God might highlight as we develop our understanding of caring with God for his creation.
Thank you.
So, Marcus, I could either go for the next 15 minutes, or we can break now, or what do you want to do?
Yeah, let's do a break.
Mm-hmm.
We have almost 1 hour.
Mm-hmm.
We covered 1 hour. Let's do a break, and then let's come back after break, half an hour break, and coming back. And I think we leave it open here, that when somebody wants to discuss with you, then it's still there, but the lecture will go on in half an hour, and then for 1 hour more, and then I will raise some question and we do some reflection.
Yes.
Is it okay?
That's great. That's really good. Yes.
Great. Thank you.
Thank you. Great.
Please.
Yeah. Next is screen to share. And you see that? Yeah. So we're going to mainly talk about the problems, the consequences of climate change, and this will help us picture why I say these things are quite urgent to address. So we touched on this idea yesterday, and I'm just going to go a bit more detail about the relationship between stopping emissions, which is called mitigation, because you reduce the problem, and then adaptation, where you adapt to changes, and then suffering. So this guy, John Holdren, a very eminent scientist, actually helped Barack Obama. And at the launch of a big international report on climate, he said this about climate change. We basically have 3 choices: mitigation, adaptation, suffering. And we are going to do some of each. The question is what the mix is going to be. What will be the mixture? Is there more of this, or more of the other? And this is the equation. The more mitigation we do, the less adaptation will be required, and the less suffering there will be. Can you imagine what we're saying here? That if we can do more reductions, then we have to adapt a bit less, because the changes will be less. And whatever happens, we can end up with quite a lot of suffering, but the more mitigation and adaptation, the less suffering. So I'll give you some examples. Here's an example. I spotted it in a church I was visiting in England, and they found that the original grey pipe that took water from a roof was always, these days, not big enough, because often the rain these days is more intense. That's because warmer temperatures can hold more moisture. In fact, quite a lot more. If you increase by 10 degrees, I think it's about 3 times more moisture. So then you have heavy rainfall. So good, look, adaptation, they built another one. You see that? So now that roof does not flood, it can cope with the rain. That's a little, very cheap step that's saved from hundreds of thousands of pounds compared to flooding. So that's adaptation. Another adaptation might be, if it's very hot, you buy another air conditioner. Another adaptation might be, if it's very hot, you don't grow wheat, you grow a different sort of crop which can cope with high temperatures. So these are adaptations. Do you understand? Another adaptation, if the sea is coming higher, you move your house up the hill. And that's happening a lot. And so just to picture this, maybe it's obvious, but every additional amount of global warming, the changes get larger. So sometimes in the international agreements, we talk about 1.5 degrees or 2 degrees. That matters, but it's not as though it steps up. There's a continuous thing, and every half degree or fraction of a degree really, really matters. And also look at this one, you can see that the middle latitudes, they warm less, whereas it's the polar areas that warm a lot more. In fact, I mean, Europe is warming twice as fast as the global average, and the poles are about 4 times more. So, okay, past. Right, let's look at some extreme weather. And I'll try to illustrate how this impacts us. So this was a particular flooding in Edinburgh. Nobody died, it wasn't a disaster, but it flooded lots of houses and a shopping centre. So what was interesting? The firstly, it's interesting that so much rain, they did not expect so much rain to fall. They hadn't planned for it, the drains were overwhelmed. Because half of July's rain fell in half an hour. Or 1 hour. But the leader of the council said something which I now say is stupid. He said, no city in the world could cope with this much rain, it fell too heavily. That's not true. There are many cities in the world which get much more rain in that 1 hour than they can cope, because they expect it. The difference is Scotland, even though we are very used to a lot of rain, we're not used to intense heavy rain, because it doesn't happen. But now it does happen. There's been this big change. So let's have a look at some effects. I'll just read these because they're probably small on your screen. We get more floods, more heat waves, droughts. We also get more extreme cold sometimes. Very high.
Is this us? Are you
The Wi-Fi is slow. I was just trying to do something and it was so annoying.
Yeah, we have it. What did he say?
You check with India and then,
India, can you hear us?